Picture a warehouse floor in 2026 where half the workers don't need lunch breaks, don't get tired, and run on lithium instead of coffee. That's not a concept video anymore. It's happening in real facilities, right now, and the robots doing it come from a race more competitive than most people realize. Humanoid robots matter today because three things finally lined up at once. AI models smart enough to understand messy, real-world environments, batteries and actuators cheap enough to mass-produce, and companies willing to bet billions on the idea that a two-legged, two-armed machine is the most useful shape a robot can have. 2026 is the year several of these machines left the lab and started working paid jobs. This ranking isn't official. It's an editorial judgment built on four things: how advanced the AI actually is, how capable the hands and mobility are, how close the robot is to real commercial use, and what's been independently verified versus simply announced. Let's count down. Number 10 is Robotics 4NE1, a German machine designed alongside Porsche's design studio. It can reportedly lift up to 100 kilograms and runs on NVIDIA's Isaac GR00T AI platform with a tactile artificial skin for safe contact. Its ambition is real, but as of now, it has no confirmed field deployment. It's still in pre-order territory. Number 9, Engine AI's SE01, out of Shenzhen. This robot specialty is walking, a genuinely human-like gait built from reinforcement learning rather than pre-programmed steps, reportedly hitting speeds around 2 meters per second. With 32 degrees of freedom, it's mechanically impressive, but its battery life, cited around 2 hours, and limited commercial footprint keep it lower on this list. Number 8 is Sanctuary AI's Phoenix, a Canadian robot often praised for having some of the most dexterous hands in the industry. Demonstrations have shown it handling delicate manipulation tasks, like assembling small parts. Its challenge is scale. Dexterity alone doesn't guarantee commercial deployment, and Phoenix remains mostly in pilot and demonstration settings. Number 7, 1X Technologies NEO, is the clearest bet on the home. Unlike most robots on this list built for factories, NEO is designed to eventually work in your living room, and 1X has open pre-orders in the United States. Its soft, lightweight build prioritizes safety around people over raw strength, which is exactly what a home robot needs. But home reliability is a much harder problem than factory reliability, and it's still early. Number 6 is Agility Robotics Digit, and this is where things get serious. Digit isn't just a demo. It's been tested inside Amazon warehouse operations, and Agility sells it through a robots-as-a-service model to logistics customers. It's not the flashiest machine here, but it might be the most quietly proven. Number 5, Aptronix Apollo, has real skin in the game at Mercedes-Benz, where it's been used in manufacturing pilot programs. Apollo's design leans industrial first. Strong payload capacity, straightforward tasks, and a company culture built around getting into real factories rather than viral videos. Number 4 is Unitree's G1 from China, and it earns its spot for one simple reason: accessibility. At a price point around $13,000, it's one of the only advanced humanoids an actual research lab or small business can simply buy today. It's not the most powerful robot here, but it may be doing more to democratize humanoid robotics than anything else on this list. Now the top 3, and this is where the real race is happening. Number 3, Boston Dynamics Atlas. This is the company that spent over a decade building the most athletically impressive robot on Earth, and its electric successor kept that reputation while gaining industrial durability. Atlas is now being tested inside Hyundai's factories, and in a major 2026 development, Boston Dynamics partnered with Google DeepMind to bring Gemini's AI models into Atlas's brain. That combination of elite hardware and frontier-level AI reasoning is exactly why Atlas sits at number 3, genuinely powerful, but still earlier in commercial deployment than the 2 robots ahead of it. Number 2, Figure's Robot. Figure earned this spot through evidence, not promises. Its earlier generation logged over 1,000 hours working BMW's Spartanburg plant, supporting production of tens of thousands of vehicles. That real-world data helped train its newer generation, which BMW has since expanded to a second European facility, a customer choosing to scale up, which is one of the strongest signals in this entire industry. Figure has also built its own in-house AI model rather than relying solely on outside partners, treating intelligence as its core advantage. Number 1. Tesla Optimus. Tesla lands here not because it has the most proof today, but because no competitor can match its manufacturing scale, capital, and vertical integration. Optimus reuses AI systems developed for full self-driving, and its next generation is expected to run on Tesla's custom AI5 chip. To be clear, Tesla has not published verified production numbers, and Elon Musk himself said in early 2026 that Optimus wasn't yet doing material factory work. This is a bet on the future, not a finished product. But if Tesla executes, its scale advantage is nearly impossible for anyone else to replicate. Comparing the top 3 directly, Figure currently leads on demonstrated commercial reliability. Atlas leads on raw hardware sophistication, and now frontier AI integration through Gemini. Tesla leads on long-term manufacturing potential and price ambition, targeting a future cost far below its rivals, though that price point remains unproven at scale. Looking forward, humanoid robots are expected to expand into healthcare support, warehouse logistics, and eventually elder care, as aging populations in the U.S. and beyond create rising demand for physical assistance. These are realistic possibilities, not guarantees. Safety, reliability, and cost still stand between today's demos and tomorrow's daily use.